In this question we have to show that D of G and F is equals to maximum of mod f of x minus g of x in mod is metric on C of A comma B. Now from here x belongs to A comma B in closed interval. Now here is parts. So part first is D of f comma g is equals to 0 and it is max. So from here we are assuming that f mod f of x minus g of x is equals to 0 for all x belongs to A comma B. Now f of x is equals to g of x in mod, or here minus g of x in mod for all x belongs to A comma B. Now the same part have subparts of question. So the second part says that if f of x is not equal to g of x, so in this case max of mod f of x minus g of x is greater than 0. Since D of f comma g is greater than 0, if f of x minus g of x in mod is greater than 0. Now moving further, the third part says if D of f comma g is equals to max such that f of mod f of x minus g of x x belongs to A comma B. Now max, or we can say maximum, x belongs to A comma B g of x minus f of x here D of gf function is equals to, or we can say D of f comma g is equals to D of g comma f for all f comma g belongs to given range A comma B. Now the last part says that D of f comma g is equals to max such that f of fx minus g of x plus p of x minus p of x in mod such that x belongs to in range a comma b. Now from here maximum is greater than equal to f of fx minus p of x plus maximum p of x minus p of x for x belongs to a comma b. So the conclusion says that f of fx minus g of x is metric on C with closed range a comma b. This is our final conclusion, or we can say this is our final answer of the given question.